How's it going, everybody? This is Frank DA3 coming at you today with a 2017 Prostar with a Cummins Isx engine. We're going to be talking about diagnostic trouble code 4156. It's going to be the heater relay circuit for the DEF system. I'm going to try to make this as quick as possible so that I can get it out today, because there's not that many videos out there, and the whole purpose of this video is to let you know, trust the literature, trust your knowledge and your common sense, and stick to the easiest problem first. Okay? We're going to go through the setup and how you trace down the circuits and whatnot. Talk a little bit about the literature, but I wanted to put this video out there so that you don't get lost down a rabbit hole the way somebody did, not me, a friend of mine, and hopefully you'll be able to find the repair, or at least get started to find the repair a lot quicker. Alright, let's talk a little bit first about relay circuits. I'm going to have some diagrams that are going to overlap the screen, and you need to understand the way, just a basic understanding of the way electric circuits work, understanding of voltage or potential difference, understand that the computer is reading both voltage and current, and understand that the ECMs in most new cars nowadays are actually providing ground, and what that allows them to do is also measure the potential difference or the voltage in a circuit, so that that's how the computers know that there's something wrong when there's not 12 volts at the computer when there should be 12 volts before it grounds it down. Take a quick look at the literature for both from International, the wiring diagrams from International or Navistar, and the solutions or trouble code repair information from Cummins Isx. Trust that. If you've got software out there with either Cummins Isx, I know CAT ET, the electronics technician, is the same way. It offers repair information. It tells you what circuits to look for. I haven't had an opportunity to use the Detroit software or the MaxForce or the Mac or the Volvo, but for those of us out there with diesel laptops, you know, I can tell you that for sure Cummins Isx offers repair information, as does CAT ET. Let's take a look real quick at the literature. Okay, this is what comes up in Cummins Isx for fault code 4156, after treatment 1, diesel exhaust fluid dosing unit heater relay circuit, voltage below normal or shorter to a low source. It's important to understand that that is what is being read at the ECM. Okay, and as you can see here, the diagrams that it gives you, I made some notes here, but you can see from the very beginning it gives you just a picture of one relay. Okay, I'm going to tell you right now, trust the literature, go straight to this relay. Okay, it's confusing, it confused me, you know, the heater relay circuit. Okay, for those of us that have dealt with DEF tanks and all the issues that they've had with the DEF system and the quality level sensors and this and that, the power distribution module for the DEF system is actually mounted behind here. And just real quick, it just occurred to me that the power distribution module is not listed here. Okay, this is the after treatment dosing unit, which is this and that, and we'll talk a little bit about being desperate, getting desperate, and being a parts changer. Don't be a parts changer. And this is the ECM. This is the relay that is in the power distribution module for the after treatment system. Now, as I'm sure many of us have found out, just because it is within 8.5 inches here on the paper doesn't mean that this is going to be directly or that close, you know, in real life. Because as we back up here, that's where the DEF system is. The power distribution module, which has the relays, is behind there. Okay, let's pan out here. So you would think that you would come right over here where the ECM is and say, oh, it's got to be somewhere between here and there. Oh, okay, it's not going to be that bad. I mean, it's going to be a pain in the butt, right? Because you got to get around this and look through wires. Look, that might be the DEF harness. Is that the DEF harness? I'm trying to get some light in here. No, that's not the DEF harness, as I found. The DEF harness, as I looked further through the literature, you know, there's actually a connection from the power distribution module, and it connects to another harness, and then it goes to the ECM. So I was thinking, hey, maybe that's the harness. No, it's not. When you're talking about a bad wire, your very best bet is going to be to trace the wire. Okay. Anyway, let's get back to that power distribution module, and we'll talk more about tracing that wire. But just so you know, what it's telling you, since it only lists one relay, what it's telling you is that the control wire, okay, and in fact I'll just use this little diagram. You've got battery voltage coming in to the relay. You've got your coil here, your activation coil. It's going to close the relay, and this is activated by the ECM. Okay, the ECM is going to supply ground, which is then going to close the switch, which is then going to supply power to your dosing unit. Okay, what this code is telling you is that this relay is not receiving ground. There is an open here somewhere. Okay, when the ECM does not supply ground, well, and I'll edit this in, if you look here further at the literature, it will tell you, oh, here's a blank page, same thing, without my notes. It will tell you right here the conditions for setting the code, and this is real important. It happens when the ECM detected the after-treatment diesel exhaust dosing unit heater relay signal was out of range low. Okay? Signal. That's important to remember. And it tells you, here it is, this is what I was looking for. The diagnostic runs when the after-treatment diesel exhaust fluid dosing unit heater is commanded off. Okay? Let's go back to electric circuits. When it's commanded off. Okay? So when this cuts the ground or turns it off, there should be 12 volts here. Okay? So once you connect the circuit together, goes through the coil in the relay, all this is going to have 12 volts until it grounds. Okay? So what it's telling you there is that when it cuts the ground, the ECM should measure 12 volts here. There should be 12 volts. That's how it tells the integrity of this entire circuit. And it's the same thing with sensors, that it tells you, hey, there's an open circuit. That's how it does it. The computer cuts the ground, so there should now be 12 volts here coming from this wire. Okay? And it's telling you, hey, I'm not getting 12 volts here. There's something wrong here. So let's just stick with this. Okay? And as you can see, this does not go through any modules. It doesn't go through any sensors. It goes from the relay to the ECM. Okay? That's not to say that it won't go through connectors, because it could go through connectors. In fact, it does go through connectors. But anyway, let's go and take a look at this relay. And so you can see what the power distribution module looks like and the steps I took to trace it. Okay, we're on the creeper now. We're crawling under. There's our drive shaft. We're looking over at the driver's side. This is the back of our DEF tank. Inside this cage is where both our fluid dosing unit goes and our power distribution module. After you disassemble everything, I'm going to go ahead and pull this out for now. Okay, this is mounted facing up, right inside there. You can see the bracket there and the other bracket on the other side. It faces up. Don't ask me why. I mean, obviously there's not a lot of room under here, but regardless, this is what your power distribution module looks like. It's upside down. There we go. Okay, this is what I'm talking about when I'm talking about the rabbit hole. heater relay. If you look here, there are the relays: backflow, pressure, suction, supply module, just like the literature said, which is R4. They're labeled there, 1, 2, 3, 4, and ignition. Oh, there's not a heater relay. Where's the heater relay? Well, let me look at these fuses. Oh, heater lines. Oh, supply module, heater. Oh, that must be what it's talking about. It's got to be one of these, right? So let's take a look at all of this rat's nest under here. And when I start tracing wires, what I'll do, I'll put, okay, there's 2 big dashes there. I've got another one here following from the fuse. It's labeled heaters. It's got to be heaters, right? Okay, this line I'm going to trace with 3 dashes. This one has 2 dashes. Let me trace and make sure that there's not an open, and you know, there's our connector. Nope. This is what's frustrating a lot of times. It just goes up there and loops and comes right back. You know, that heater fuse right there feeds these other relays. Okay, let me trace back those, and are these working? And again, like I was mentioning earlier, you would think it would go right from the DEF tank just right up there to the ECM, you know. Nah. What I ended up doing after sitting there tracing my tail, making sure that these lines were all good to go and had good continuity, I went back to the literature, went back to that single relay. This is the supply module relay. That is my control side. Okay, it's going to be pin 86. Pin 86 in your 4 pin relays. Pin 86 is always the control. Okay, and I don't. Oh yeah, here it is. I don't know if you can see in there. Pin 86 right there. Pin 86 is your control. Okay, so what I did was I tapped into pin 86 and started with my which is helpful, but you got to make sure you got good batteries on the receiver. My power probe short and open loop finder. The problem with this is that had it been an issue with the fuse, this fuse runs all these relays, so you've got power going through all these wires, right? So it's going to feed the signal through all those wires. The benefit of the power of the control on this particular relay is that there's only one wire. It doesn't splice anywhere. Okay, so trust your gut. It's going to take time. It's time consuming. It did help somewhat to use that tracer, but it goes up from here. It goes up, that single wire goes up right above the DEF tank. It loops around and it's just folded. So I thought, oh, there's some sharp bends there, or maybe it's there. Nope. Then it comes across the cross member, and you can kind of see right there where I opened it up. Still got the signal there. Okay, you know. And then it continues over, back over here. And I'm going to show you where the DEF harness is. There are 2 ways that I use to check for continuity. The signal sent out by your power probe, for those of you that have got the power probe short and open finder, the transmitter, what this does is that I can plug this in. In fact, that's what it's for. This is from the power probe set. Plug that in there and it sends a signal, and I'll show you the little receiver. And it beeps, but I don't know if the batteries are going down. I mean, in fact, I think it's the second time I use it. So sometimes you lose the signal, so you got to open up the harness, and you shouldn't be losing the signal. You know, so I think the batteries were low. Another way you can do it is to set up a voltmeter, which is ultimately what I ended up doing, and I've got it over here now. But you set a voltmeter, digital voltmeter, to your circuit check, your continuity test. And that's where this comes in. That's where this is the ground probe to my voltmeter. Okay, now I've got that on there. So now what I can do is check for continuity between that terminal, which runs that single wire all through there, and I'm going to show you where it goes. Blah, blah, blah. Anyway, the passenger side comes all the way back, attach it to my positive terminal on my DVM, and beep. If I've got continuity, I should get a beep. There should be 0 ohms, or very close to 0 ohms, right? From there, anyway, it continues all the way back to the ECM. We get out of here and we'll continue. If you looked at the literature, and people will, and it's, I mean, you can do it to open up the connector at the ECM, because if you're like me and you're looking through and doing your research, let's see, where are my pinouts? You go to your pinouts. This is the connector I'll tell you about here in a little bit, the DEF harness. But if you go to your ECM connector, okay, you know, it should be, oh, these are all grounds that are supplied to the different module, to the different relays. This is the one I'm looking for. Okay, pin number 7. Okay, I marked it there. Okay, all I got to do now is check for continuity there. But the thing is, this is already telling you. That's why you got this code. This code is telling you, hey man, there's something wrong here. I'm not getting 12 volts. When I cut the ground, I'm not ending up with 12 volts. Again, remember, it comes on when it's commanded off. It cuts the ground, right? So I should get 12 volts here now. I'm not getting 12 volts. So, I mean, yes, I could check for continuity in here at the ECM, but okay, now what? Okay, I don't have continuity. Now what? Well, I gotta trace the wire anyway, right? So anyway, oh yeah, man, I got the mobile card out. I got my electric card out. Oh, this has been a joy. So now you keep tracing that wire, and I'm gonna get a light. Yeah, I'm using my light buddy here, my headlight. Anyway, it comes, there's the harness there. It comes all the way, and we'll skip past what I was going to tell you about. And there's our harness, okay? That's our DEF harness. I think it's number 674, I think. I'm not sure, but I'll show you there on the pinouts here in a little bit. It connects from here, and then it keeps going. Yeah, that's where it connects, and then it keeps going, right? I don't know why. I mean, I just don't know why. I mean, I think because it picks up. This is where our diesel particulate filter is, our SCR, all that is on this side. So I think it actually ties in here, you know, and then it continues. So regardless, I had the signal, and the signal did work for me here. I lost the signal somewhere around here. Hey, what happened? You know, and I tried to plug it back in. Okay, you know, when I was using the signal transmitter, then I'm like, man, you know, this stupid thing isn't working right. So I'd get a beep or two and then nothing. So I just set up a continuity test, right? So I'm going from the relay all the way around, you know, back to here. Actually, I'm going from my voltmeter, from the black common terminal, or the negative, to the relay all the way around. I'm making a big loop. That's all I'm doing. Just making a big circle. Coming all the way around. And of course I've got my leads out here, but you know, still, it's the same principle. It's just a gigantic circle now. Through here, through the green, out the green, and to my positive. If I've got continuity, I should get a beep. And I'm not getting a beep. Okay, well, let's check if we've got any high resistance. So that, you know, a lot of corrosion is giving you real high resistance, which is going to cause a drop in voltage, right? It says it's below normal, right? Open or below normal. Okay, look there, and I'm running on checking my resistance I've got it on the ohm scale, and I've got open loop. Okay, so I checked the pin out. It's pin number. There's pin 6. It's either 6 or 17, right? Those are the only ones that are coming from this circuit. 6 or 17. I hooked it up to both of them. I just left it on 6 for now, just so you guys get the general principle. But I've got an open loop. Let's put it on 17 just to show it. Okay, now move it over to pin 17. Those are my only two possibles, and I've still got an open loop. Okay? Alright, so I know that my problem is somewhere between here and the relay. So I started going back. When I lost the signal, I started going back a little bit. Let me switch my light to spot mode. And lo and behold, it's hidden now, of course. Get it out of the way. There we go. And lo and behold, see if I can get the light in there. Look what I found. Focus, baby. Look what I found. It's not focusing because it's at a pretty weird angle. Anyway, you can see that it is pretty badly corroded, and so corroded, in fact, that I'm trying to do this with one hand. With the left hand. Where is it? Okay, there it is. So corroded, in fact, that look at the loom. That was a big indicator for me. Look at the wire loom. It's got that corrosion crap all over it. That's how long it was sitting there getting wet and corroding, getting wet and corroding. I mean, shit was dripping out all over the wire loom. Okay? And just so you know, I did take my little probe here, and again, there we go, same thing. And I poked it just on the other side of the corrosion. Beep, got my beep. So I know that's my problem. And now it's time to, I gotta tear out the holders, the wire ties for that harness, and drop it down so that I can solder on a new piece of wire. Okay. Trust your instincts. Trust your instincts. Listen to the literature. But that's a 4156 heater relay circuit. This diagram came right out of Insight. Listen to it. Alright, there's a fresh copy. This is all it comes to as soon as you tap it on there. You know, Insight's pretty good. Gives you what causes it, possible causes. And here's the thing, I saw a video, this is another point I wanted to make. I saw a video where somebody says, oh yeah, that means the dosing unit's in, will you replace the dosing unit? That's a parts changer, right? Experience tells us, and I've called the techs here at the local international shop, when you're talking about your NOx sensors, NOx, for the inlet and outlet at the exhaust, for the inlet and outlet exhaust sensors, the Navistar tech tells you don't even mess with it. All that wiring is incredibly shielded. It's the sensor. We don't even mess with it. We replace the sensors. It's done. And we do the same thing here. I change out the NOx sensors on these things every 2 years or so, year and a half, you know. But when you're talking about a wiring issue where you know that it's talking about a relay, so if the relay's good, you know there's a problem in the circuit. For this particular code, it's telling you that it is this wire. It's exactly what it's telling you. Either the relay's bad or it's this wire. And another good thing about the Insight, it gives you some repair tips, you know. Possible causes: malfunction of the dosing unit heater relay, which is that relay, a short circuit to ground in the OEM harness, or an open circuit in the OEM harness. Okay? Doesn't say anything about replacing the dosing unit, but I'll be in full transparency. We had to get this truck out because I didn't think I was going to have an extra truck for my driver. Had to get this truck out. I happened to have an extra dosing unit because I got a super deal on 2 of them. And yes, I said, you know what, the hell with it. Let's just swap it out, because this is actually pretty easy to get on and off. Let's swap it out and see if it works. You know, just how embarrassing it is. But you know what? we've all done it, I think. And sure enough, well, it didn't work. Okay, well, oh well, you know. Luckily, we got another truck, blah, blah, blah. But it doesn't say anything here about, oh yeah, your dosing unit might be bad. There will be another fault code for that. Okay, guys? If it's your dosing unit, there will be another fault code. This fault code, this is the repair information it gives you. I mean, it tells you this is the only relay that's talking about, so obviously this is going to be, this is what it means when it's the dosing unit heater relay. Understand that this is the international setup, right? With the def tank, and it's even changed. This is a 2017, right? Your Freightliners are going to be different. Your Peterbilts are going to be different. Your Kenworths are going to be different. Volvo, Mack, they're all going to have a different setup for the def, right? But this is an IXX diagnostic, and so it's going to just call it a heater relay. Believe me, I called, hey, where's the heater relay? They're telling me about the heater valve to heat up the def tank. No, and I checked that, and that's not it. When what I should have done from the beginning was just gone with this, right? You understand a little bit about electric circuits, you'll be fine. But I saw a video, oh yeah, just open it up right here, and this is where this is where, you know, the problem is, and no, it's not. Because it goes from there, in this particular application, right? Because it goes from there, and even this, I'm not even sure. I'm not a diesel tech by trade, right? It's going to be one of those. There's your ECM. And it goes down, and who knows where it branches off here before it goes back to that harness. You can look at the different, here's an, I mean, man, I've got this, and this is tying to this right here, and holy cow, blah, 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 when I should have stuck with this, right? Here's that def tank harness I was talking about. So I know it's going to be either 6 or 17, right? This is the my ECM connector. It would have been 3 or 7 at the ECM, but that split that we have, that's that harness that I opened up. You can also find pinouts. This is all in the, this is all the circuit identifications for Navistar. They've got all the diagrams for all the different configurations, so they're kind of a pain in the ass to look at sometimes. Here are my pinouts. This is the power distribution block. And yeah. Here's the def harness connector, number 674. Where's my right here? 674, right? This is what it looks like on a diagram. This is what the pinout looks like, right? So I know it was going to be either number 6, 95M, or 17. No, in fact, it's not even right on this one. Where did I find it? I think it's this one over here. Because there's 2 or 3 different setup configurations for this harness. Anyway, trust your instincts, trust your knowledge, stick to the basics, right? Don't climb down the rabbit hole, tracing wires galore, which all that I opened up that you saw down there, that had to be opened up anyway, because the unit faces up, and I didn't want to put a probe in there and be bending it over with a connector on top of it and stuff like that. Plus, this way I could back probe it. I actually started by back probing all these, and it just turned into a mess. But trust your instincts, right? Diagnostic trouble code 4156. Your heater relay in Cummins Insight. Stick to this wire. I just got notes. Stick to this wire, your control wire. When it cuts the, remember, it happens when it's commanded off. The diagnostic runs when the dosing unit heater is commanded off, which means it cuts the ground here. So this relay should open. I'm sorry. This relay should open, but there should be 12 volts all the way here, and the computer is not measuring 12 volts, which means, hey man, there's a problem here somewhere. There should be 12 volts here until I ground it down. And there we go. I wanted to splice it open to show you how the wires were making little if any contact. And I cut through the insulation and it just came apart there. Yeah, we had a complete break there. One thing to take note, what I'm going to do also, you've got a couple of other wires in there that have looked like they got some damage to the insulation. Before it breaks through, I'm going to make sure I tape that up real well. I'm going to solder on a little piece of wire here. And before you wrap everything up, I'm going to test it, put back on my dosing unit, and run a test. Good thing about these codes, as soon as it reads that it's working properly, that DTC will go inactive. And then I'll go back in there, wrap everything up, and put everything back the way it was. So thank goodness I found it. And you still want to check, because you never know. You just never know. Maybe this was just making a little tiny bit of contact and there's a bigger problem. Hopefully not. I wish I hadn't even said that. But it's best to check everything before you put everything completely back together. Okay, all right, just wanted to get a little video real quick of the repair. Got the shrink wrap on this side already. You can see what it's going to look like. I've joined the wires together, just kind of let them interlock. I can't do it with, I got the phone with one hand, but have them interlock the wires. Interlock the wires. I think that makes the best and slimmest profile. Shit, well, I wanted to show you what this one looked like, but the shrink wrap's getting in the way. Anyway, there it goes. That's what that end looks like. You want to keep it as slim profile as possible so it's not stuck on the other side, so that you can wrap up everything and tape it. I got another piece of shrink wrap up there wedged in there. But we're going to solder this back up. This is what I was also mentioning earlier. Shit. That there's a little damage to the wires. You can see there. See that red wire and that other tan wire. I'm going to tape that up to give it a little extra protection before that. Because once it breaks through that the insulation, it's going to start corroding. So before it gets to that point, I'm going to go ahead and fix that. And we'll button it all up. Get the giant. I got some big wire ties. Tie this back up to the top along the rail out there. Blah blah blah, and we'll keep going. All right, guys. I hope this was helpful. And keep trucking, man. Keep trucking. Thanks for watching. This is actually the first commercial truck video that I put out, but I look on YouTube for answers just like everybody else. Look at this mess. Anyway, time to start putting this thing back together. Y'all have a great day.